Thank you for attending my talk, CSS Display Properties versus HTML Semantics. We have a bunch of things that we are going to cover in this talk. I've put together a quick agenda, but don't worry about that so much. I'll get to everything here. Hi, I am Adrian Roselli. I have been building for the web since 1993. You can learn more about me on my site, adrianroselli.com. You can also avoid me on Twitter or block me right now at Adrian, that's A-A-R-D-R-I-A-N. For a little bit of context, so that you know the person who is speaking might have some experience in this stuff or have a bit of a clue. I've written some books. I've written a bunch of magazine articles. I was one of the co-founders of evolt.org, used to write for Web Standards Sherpa. I have a few resource sites like Does My Site Deserve Recognition and A11Y Reviews. I've participated in WA3 standards creation for years. I'm one of the people behind Inclusive Design 24, and I do accessibility editorial work over at A List Apart. So let's talk about an example use case for the overall range of my slides here. Think about an HTML structure that challenges developers across screen sizes and contexts. Think about something where you have to build a layout that can adapt to screen sizes, something that has an inbuilt structure with inbuilt semantics, where the nodes that are exposed in the accessibility tree have to be put together in the DOM in a very particular way. The example I'm going to use is HTML tables. It's a great way to present information in two axes. They kind of are the perfect proxy for everything I want to do. So let's recap them really quickly. HTML tables have a long history on the web. They have been used not just for tabular data, but also for layout. Since they were first introduced, that was kind of their thing. They have a very specific DOM structure. If you leave nodes out, the thing can fall apart. They also have their own navigation methods within screen readers, for example. A basic HTML table, pretty straightforward. Avoid spanning cells, make sure you use TH for headers, add a useful caption. I mean, realistically, coding tables is pretty easy, even if it might be a bit monotonous. The idea is that it's a series of rows consistently coded with a header for each column and a caption. In my example here, I have a table that shows authors in one column, titles in another, and years of their books in the final column. Now you can start to add some complexities to tables. Row headers is one of those complexities. You would still use a TH element, but you would add scope attribute and choose a value as appropriate. Scope attributes that are valid include row, col, row group, and col group. And making sure that your row headers are well coded conforms to WCAG technique H63, using the scope attribute to associate header cells and data cells in data tables. So this is a pretty straightforward bit of complexity. In the example I'm showing here, it's phone numbers and fax numbers and cities for some people, and those people's names are essentially the row headers. Now we can make it a little bit more complex. Complexity number 2 would be some spanning cells. You'd still use a TH, but every TH at that point gets its own ID, and then every TD, every individual cell gets a headers attribute, and the headers attribute points to the ID or IDs of the TH or THs that you want it to reference. This conforms to WCAG 2.0 technique H43, using ID and headers attributes to associate data cells with header cells in data tables. Now, generally, spanning is a bad idea. It has its place. This example shows homework assignments or homework percentage when factoring in grades, and compares it to exams and projects across 2 semesters. And it uses exams spanning 3 columns and projects spanning 3 columns to compare first semester, second semester, and then a final exam. This example and the previous example are both lifted from W3C documents showing how to correctly code tables and these 2 variations of complexity. Now, responsive design may have been the cause of some of the resistance to tables that we see today. A lot of developers are very uncomfortable using tables. They think that they are the antithesis of good development practices. Lists have fared much better for a variety of reasons. So let's look a little bit at how responsiveness complicates things. Specifically for the next few slides, I'm going to talk about viewport width. There's a lot more to responsiveness, but just viewport width for this. Again, their tables are typically the bane of the typical responsive developer, but I'm showing you here probably the easiest and least risky approach to make a responsive table. And namely, that's letting it scroll off screen. Put it in a container, add a tab index of 0 to that container so that a keyboard user can tab to it and then arrow right or left to scroll the view. Add a role region so that screen readers announce it, and add aria labeled by so screen readers will give it a name. And ideally, aria labeled by will point to the ID of the table's caption. Simple example here, using my books table, added a couple more columns, and we can see it's too wide for that narrow view. So there's a scroll bar sitting at the bottom. That's it, tab to it, scroll back and forth, and you're in good shape. Now, responsive is more than just viewport width. Even if it were just viewport width, a scrolling table might not cut it. I'm still using tables as the example, but your requirements might demand some visual restructuring. One example is having your tables respond to print, because print is a media query, just like width, so you ideally would still need to support it. Similarly, there's Windows High Contrast Mode or other display settings, and these are feature queries. Ideally, you do nothing on a simple table. If you're using background colors or background images, obviously this can complicate things a bit. Now, you might want to try a more novel way of adapting to a narrow width. One thing you can do is rearrange the table cells using CSS. CSS display properties, block, grid, and flex can all be pretty powerful to do this. In the animated example here, I'm showing how the table gets narrower and narrower and the text wraps up to a point where it becomes too narrow, and then the table restructures itself. And it stacks all the cells on top of one another. And even when the viewport is too narrow to fit all of the width of the text, there's still a scroll bar on it. So I've got sort of a best of both worlds. I can still stack it. And in those very rare cases where somebody's scaled the text a lot and they're on a smaller device, they can still at least scroll to see everything. The CSS I'm showing here, pretty straightforward. I convert everything in the table to block, the table, the TR, and the TD to make the layout easier, dumping all of the table, row, and cell styling. And then for the individual cells, to make the layout easier, I set it as display grid. And then I add my headings, the column headings, as inline text. Just a little bit of a view of it in the editor so you can see how everything comes together. Now, let's talk a little bit about CSS display properties. The following properties are going to override native semantics in the browser. This isn't necessarily how it should be, but display block, inline, grid, flex, or contents are all going to remove the semantics. You can't use CSS to add it back in either. So if you're using any of these display properties, there's the risk that whatever your structure or semantics are can be blown away. Nothing in the HTML nor CSS specifications mandates this. Again, can't add display table or display table cell and make the semantics magically come back. When it comes to assistive technology, the browsers aren't conveying those semantics to assistive technology. So a screen reader, for example, isn't going to know that something is a table. So for users who rely on the semantics from a table, they can be stranded. They might not be able to understand the content. Rows and columns and those relationships fall apart. It also means they might not be able to navigate the content, maybe the entire page, depending on how much information you have. So I look at tables as sort of a canary in a coal mine. Breaking semantics of any single required child element of a table can break the entire table. If you're missing a row or a column or row header, or if the parent table has rows and spans that have been overridden by CSS display properties, the whole thing falls down. You can get a miscount of rows or columns, so it tells you a number that isn't accurate. Headers can be associated with the wrong data. And it's hard to see this in action with elements that don't have so many required children. Lists don't make this as visible. So think of tables as sort of code smell. If your table is broken because of CSS, you might have this problem somewhere else in your code. Now I have an example here of GitHub and how it implements tables by default. It wants tables to scroll because it's very easy for a table to become wider than their layout, not the viewport, but their fixed width layout or their maximum fixed width layout. So what they do is they put display block on the table element instead. They don't put it in a scrolling container, they make the table scrollable. And they do that with dot markdown dash body table display block. That makes the table useless to screen reader users and useless to keyboard users because there's not even a tab stop. There's no tab index equals 0 on that table to allow them to scroll back and forth. So looking at the example table I had before, if I restructure that layout just as it is, don't do anything else except use the CSS to make it responsive, it falls down in a screen reader. So what I've done here is I've paired up Firefox with NVDA. I'm probably not going to let the whole thing play, but essentially I'm hitting T to get to the table. Then I'm using Control, Alt, and arrow keys to navigate the table.
Books I may or may not have read. Region. Books I may or may not have read. Table with 7 rows and 5 columns. Books I may or may not have read.
I should qualify that this is actually the table with the correct semantics before I've applied the display properties. And then I've gone and broken it because I jumped ahead.
Books I may or may not have read. Region. Books I may or may not have read. Table with 7 rows and 5 columns. Books I may or may not have read. Row 1, column 1, author. Row 2, Miguel de Cervantes. Title, column 2, The Ingenious Gentleman Don Quixote of La Mancha. Year, column 3, 1605. Row 3, 1818. Title, column 2, Frankenstein, or The Modern Prometheus. Author, column 1, Mary Shelley.
So we could hear that the table, that NVDA rather, was announcing the columns as I jumped around, and it told me the column position and row position. Once I add display properties though, and I use those same commands to try to navigate the table, things are a little bit different.
No next table. Not in a table cell. Author, Miguel de Cervantes. Title, The Ingenious Gentleman Don Quixote of La Mancha. Year, 1605. Not in a table cell. ISBN 13-97831.
The gist there is that it doesn't recognize that there's a table on the page, and I can no longer navigate using standard screen reader navigation, table navigation commands. That's why NVDA keeps saying not in a table cell. So all those relationships are gone. I no longer have any sense of where I am in the table. Now, it's important to understand the role of the accessibility tree in all of this. The accessibility tree is essentially a subset, superset of the DOM, depending. It includes the user interface objects of the browser and objects of the document. So that what it does is for anything that fires an accessibility event or has a property relationship or feature which needs to be exposed, and it's in the DOM, it gets added to the accessibility tree. What we're seeing when we look at the accessibility inspector in the developer tools in Firefox or Chrome is an abstraction. It's not a one-to-one correlation for what the accessibility tree looks like. So I have here side-by-side images comparing what the accessibility tree in Chrome's inspector should look like for a standard table compared to what it looks like in the accessibility inspector when you've added any display properties. On the left, the first image, it shows it's a table with a caption, it has rows. One of those rows has the column headers, the other rows have cells. The second image, just by adding that display property, it now shows it as ignored. It has no computed properties, the accessibility node is not exposed, and that entire accessibility tree for a table has gone away. Similarly for the caption, in both cases I see a caption. The difference is once I add those display properties, that caption isn't associated with anything. It's just a piece of text floating in the accessibility tree. THs go from being a column header to becoming just an ignored element that has no accessibility properties. Same is true with TDs, cells. They go from being grid cells, which is the default way that they are exposed in the Chrome Accessibility Inspector, They go from being grid cells to being nothing. They have no structure, they are not exposed in the accessibility tree, and they have no correlation to anything else on the screen. So this is where things go all wobbly. Chrome version 80 was released on February 19th, 2020. And one of the things that it explicitly does is fixes the flex bug on tables. What that means is it no longer ignores the table semantics if you add display flex to a table. So this caused me to re-examine everything I had been looking at overall, which meant a bit of panicked slide editing just a couple weeks before CSUN. There are other fixes and changes that are part of Chrome version 80, and I'll talk a little bit about some of those. Any browsers that are based on Blink, the core engine of Chrome, are going to benefit from this change. The latest release of Edge, Chromie Edge, as opposed to the legacy Edge, will also benefit from this. So I have a screen showing a table with display properties, and I have them set to flex. And when I look at the accessibility inspector in Chrome, I can see that even with flex applied, I'm still in a table, in a row, and in a specific cell when I'm looking at any particular cell in the table. This is good because it maintains the semantics, it creates all the structures I need, or at least it retains those structures, and it all lives there in the accessibility tree. The thing that I've highlighted is a flex item in a flex container. So the good news here is progress. But there's a little bit of bad news associated with this as well. Namely, the web is not Chrome. The slide that I'm showing here is data from the WebAIM Screen Reader Survey number 8, which was released in September of 2019. So it's the most recent I have. It's a survey, which means it's not exactly perfect research, and the folks who are answering the questions skew towards more technically savvy, but it's still some good insight. What this shows is that JAWS with Chrome makes up only 22% of screen reader users. NVDA with Chrome is another 18%. We don't know how other assistive technology is handling how tables are exposed or navigated, mostly because I ran out of time to test it. Now, I put together some slides comparing what I have found. Generally, Chrome 80 on Windows 10 does well with flex, grid, block, inline block, and contents. Tables do just fine. Headers, buttons all do fine. The caveat is any lists that have display content set to them fall down and they lose all of their semantics. Firefox 73 on Windows 10 has problems with these display properties on tables. So THs with flex and grid are announced as cells. That means they lose their column or row header status. And a table with display contents just falls apart. Lists seem to fare pretty well. When it comes to display inline block or display contents, it inserts a text leaf between each list item, bit of a pickle. And then buttons, when they have display contents, Firefox will issue a keyboard use warning. Safari on macOS 10.15.2. Tables are a mess. Display flex, grid, block, inline block, or contents, your tables fall apart, period. Your lists fall apart for block, inline block, or contents, with the exception of DL, definition list, description list, dictionary list, whatever the kids are using. Headers and buttons fall apart on display contents. So right now, Safari on macOS 10.15.2 has the most trouble with CSS display properties. Chrome 80 on Android 10 matches pretty well with the desktop version of Chrome 80. It does well with flex, grid, block, inline block, and contents for tables, for lists, for headers, and buttons, with the exception of display contents on lists. It will ruin your lists. Safari on iOS, just as broken as desktop Safari. Worth noting that if you have display block, inline block, or contents on a table, then it treats all cells as belonging in column 1. kind of annoying. And a button with display contents still fires on double tap with VoiceOver. So it won't announce it as a button, but if you accidentally double tap your screen while doing Explore by Touch or using the rotor, you can accidentally trigger something. Now, I had mentioned CSS display table before. Display table, table caption, table row, and table cell are all CSS properties that people have used for years to try to replicate something like vertical centering, which wasn't always easy to do with CSS. Each of these display properties will add layout table semantics in Chrome version 80. There's no CSS display property to create column or row headers though, and this still requires a well-structured DOM. And this is not a workaround, it's not a fix, and it doesn't mean it's okay to use divs as tables. This is a hack, and it's probably not ideal. Also, Chrome doesn't really call it a table in its accessibility inspector. It refers to it as a layout table. So I'm showing the inspector, specifically the accessibility inspector, pointing at where it should be a table with a row and grid cell. I have layout table, layout row table, and layout cell table. This is problematic. JAWS and narrator will read this as a table, but it will not recognize any column or row headers because there is no CSS display property that corresponds to those. NVDA, VoiceOver, and TalkBack will not read this as a table. Slightly future curveball, in Chrome version 82, it's going to support Flex's align items property on buttons. And it's not just Flex, but also grid. So if you're using display, grid, flex, inline grid, or inline flex, and you use align items, this can help. Primarily, the lack of support for align items has hampered uptake of button in layouts that are grid or flex based because people couldn't get, or designers couldn't get the vertical centering or vertical positioning that they wanted because it would break everything. So you can expect to see more buttons with more display properties, which means more testing will be required to make sure the semantics are not being dumped. Now, there is a long aversion to tables owing to their misuse for layout, and people will try other elements and then try to throw ARIA at them. I'm really not a fan of using ARIA to fix stuff, but what we have is a potential stopgap measure we can use here. You can use ARIA to reinsert lost semantics. So if you make table with a role table, caption, role caption, I should note role caption is coming in ARIA 1.2. It does not exist today. A T-head, T-body, T-foot would get role row group. A TR gets a role of row, row cell on TD. Any TH with a scope col would be role column header, and any TH with a scope row would be role row header. So you're reinserting the semantics. This is potentially good. This isn't going to address reordered content. So if you re-lay out your table and move things around dramatically, you're still going to have some reading order issues potentially. This also doesn't address any content that you've hidden. Now, I want to caution you that you should not use grid roles, and you definitely should test with a screen reader. If your tables are generated from any scripts, you might want to update the script so that it adds these roles for you automatically, just builds them in. Incidentally, on my site, I have a JavaScript function that will add these roles for you. I don't think I included a link at the end of the slides, but you can pester me afterward and I will point you to it. Here is what your table with all of this extra ARIA might look like. It's a lot more verbose. Definitely those THs with role of column header. It's certainly got more code going on in there. The advantage though is when I fire this up in a screen reader and browser combination that is not Chrome 80, we'll hear that it's going to recognize the table. So using NVDA, I'm going to hit T to get to the table, and I'll use Control, Alt, and arrow keys to navigate the table. And if you can see what's going on, you'll note that it's navigating a table as if it's a table, but all the content is visually stacked.
Books I may or may not have read. Region table with 6 rows and 5 columns. Books I may or may not have read. Row 1 column 1 author, Miguel de Cervantes. Row 2 author, Mary Shelley. Row 3 author, Herman Melville. Column 2 title, Moby Dick, or, The Whale. Column 3 year, 1851. Row 4 year, 1888. Column 2 title, The Hidden Hand. Row 5 title, The Great Gatsby. Row 6 title, 1984.
So the gist there is that I am still able to navigate this regardless of how it looks. As a screen reader user, for that set of screen reader users who genuinely don't care what a table looks like, this is good. I mentioned ARIA Grid. Do not use ARIA Grid roles for simple tables. ARIA Grid is intended to mimic Excel style spreadsheets. You don't want to use this for data tables, and I'm not covering much more than this in the talk. Also bear in mind that ARIA Grid roles create a composite widget, which means your grid, not CSS grid, but your ARIA Grid is one tab stop in the sequence, and it contains multiple interactive controls. Every cell is editable. That's usually not the case with the data table. And it also means you as a developer have to manage the focus within that table. Display contents. I am seeing this become sort of the new hotness, or at least I've seen it become the new hotness. It is something I want to call out specifically, primarily because I see some developers using it as a sort of weird CSS reset. The way it's a quasi CSS reset is because it takes the element and makes it not generate any boxes. Children and student elements still generate boxes, but otherwise it's just a string of text on the page. It's almost as if the element has been replaced in the tree by its contents, as if its opening and closing tags were removed. It also yanks things right out of the accessibility tree completely. You can't add it back into the accessibility tree with ARIA. You can give it an accessible name and all these properties and all the roles that you want, but the browser doesn't recognize it and therefore does not pass it along to screen readers. So be very careful, because if you're using display contents, it's going to hide all of the important reasons you chose that semantic element from assistive technology. We know Chrome 80 has just addressed a bunch of issues, and I covered it in the previous slides. So I'm going to show an older version of Chrome in the following slides, which is kind of hard to do when it's always auto-updating. But this will demonstrate how you can confirm support within the browser before you even have to fire up your screen reader to do some of the testing. The image on the left shows the inspector and what the table looks like before any CSS display properties are in place. We can see that the computed properties give it a role of table, and it gets its accessible name from the caption. The image on the right shows how once I've added my display properties, the whole thing falls apart. Once I've added display contents, Once I've added display contents, it has no computed properties at all. The accessibility node is not exposed, and the element is not rendered in the accessibility tree. And you can see under the ARIA attributes section of the accessibility inspector, it still has role of table, but it's not computed as a table, so it's not handed off. The same is true in unordered lists. On the left, it's computed as a list. On the right, the accessibility is not exposed, even though I'm forcing a role of list. Same thing with button. I have ensured that it is a button by using button. Its accessible name comes from the contents of the button, and it's listening for user entry and other handlers. I add role button. While it has display contents, no dice, it's still just a piece of text, no accessibility information. With the H2, even when I add ARIA level 2 to make it an H2 with a role of heading, it doesn't get exposed. Typically, the computed properties would tell me it's a heading at level 2, but not once I add display contents. Taking the example that I showed you a few screens ago, I have a page which has a table and a list and a button and a heading, and I've set display contents on all of them. I'm going to have a few seconds here of trying to navigate that with NVDA in Firefox.
No next table. No next list. No next button. Table with display. Contents heading level 2. Books I may or may not have read. Author title year ISBN 13 ISBN 10 Miguel de Cervantes the Ingenious. Gentleman Don Quixote of La.
So I'll stop it there because I want to point out I tried to navigate to each of those element types by hitting the associated key. T for table, B for button, for example. And NVDA did not recognize them. When I start to cursor through and go right to the table, instead of announcing it as columns and rows, it reads off all the text from the first row, which are my columns, and then text into the first 2 cells of the first row. That's a bit of a problem. Now, bugs have been filed. Firefox, Chromium, Safari, and the CSS working group all have open bugs on this. Even the fixes in Chrome version 80 do not close that Chromium issue. It's still an open bug, specifically elements not exposed to accessibility tree when it is set to display contents. So the bugs are out there. Browser makers just need to do something about this. So you might ask yourself, where is my beautiful table? You may ask yourself, where are the table semantics? And you may ask yourself, why is this so broken? Really, how is this a thing? Assistive technology is not at fault here. So it's not the screen reader's fault. The accessibility information comes from the browser. Because developers used layout tables for so many years, screen readers have had to improvise. They need more than the DOM to understand the page. So they have developed heuristics for reading tables, for understanding if it's a layout table or a data table. It can't really tell when the browser isn't handing any information at all. Remember, I'm still using tables as my proxy, as my canary in the coal mine. You can't rely on detecting assistive technology to try and turn off your display properties. First of all, users don't want to be discovered as using screen readers. That's a general problem. There are some who are fine with it if they can get a genuinely more accessible experience, but evidence suggests that doesn't really pan out. Mouse user or mouse actions are a poor proxy to identify sighted screen reader users. It also doesn't map well to people who have mobility impairments or are using a mobile screen reader with touch gestures. Disabling a site CSS for screen readers is impractical. Do not do it. CSS itself is not blameless. CSS already impacts HTML semantics, so this isn't a new thing really. Display none does that today. Using display table on its own does not impart HTML table semantics. It does give some layout table semantics in Chrome, but that's not the same. CSS flex or grid makes it easy for content order and source order to disagree, and it's not just flex and grid. But ever since we've had absolute positioning and floats, we've had this problem. Think about how we've used CSS to vertically center stuff. I mentioned that for a while. That's part of how we got into where we are. Assigning table cell display properties to divs just so we could do vertical centering. And remember, if you use CSS display grid properties to lay out an HTML table, it still won't semantically be a table. First rule of ARIA, don't use ARIA. Not if you don't have to. But yeah, if you are going to use ARIA, because this is the only way to fix it right now, you must understand ARIA, the ARIA that you're using, and the table structure that you're rebuilding. So it's also going to require you to keep current on screen reader and browser support because things change. Things change rapidly now that we have browsers in development cycles that are 6 weeks, potentially 4 weeks. You'll also have to manage content that you hide when you reflow the table, such as the column headers, and you'll have to consider what happens when your CSS does not load for whatever reason. So this is not the purpose of ARIA. Everything I've shown here is just a stopgap. I also want to point out that browser is not right. The CSS spec does not state that semantics should be dropped. This is a weird decision that browsers made that doesn't seem to come from anywhere. There's no reason to remove the semantics just because of display properties. The accessibility tree should not care about most visuals. Again, display none's a great example where it should, but otherwise, it shouldn't break the semantics for something that's just changing its layout a little bit. To wrap this up, I have a slide with a bunch of references. I've written a few things about it. The first, let's see, 1, 2, 3, 4, 5. Well, everything in the left column is stuff I've written with the exception of the GitHub contributions chart. That's the example that I showed partway through where they put they try to make the table itself scroll instead of putting it in a container. Steve Faulkner has talked about display properties and table semantics. Hayden Pickering has some information in his data tables article. Adrian talks about it in how display contents works, specifically some of the benefits of using display contents and balancing a little bit against some of these challenges. And if you're curious, CSS3 Appendix B talks about the effects of display contents on unusual elements. These are all handy resources to maybe try to understand where we are or to file bugs on your own. Again, thank you for attending the talk, CSS display properties versus HTML semantics. I'm not standing right in front of you, so you can ping me with questions. Find me on Twitter is probably the easiest way after this is all over, and I'm happy to help you out. Again, I am on Twitter at Adrian, AARDRIAN. Thank you again.